Are you all in agreement that this vector will have an x component and a y component, right? If I look at this, I would say in red that this is my x, so this would be Vx, and this is my y, right? So this is Vy. Notice how I don't have a little hat on the Vx or the Vy because they are not vectors. They are parts of a vector. On their own, they're not vectors. The same thing can be said if I have a vector that looks like this. Will this vector have an x component and a y component? Yep, its x component will come out here. This, let's say we call it y, or no, I don't want to call it y. Let's call it s. Sx, and let's call this sy. Whereas this guy is your s vector, right? We're good? Okay, now, from a mathematical point of view, I can figure out the numerical value. If I know my magnitude of the v vector here, if I know, let's say I say that it's got a magnitude of 10 meters per second, an amount of 10 meters per second, okay? So if I say that v is equal to 10 meters per second, that's its amount. The meters per second are its units. If I want to figure out what the x component of that vector is, I use trig. Vx is going to be equal to the magnitude of v times the cos of the angle here, okay? This angle. This is your theta because it's the only angle there, okay? So if I say that my angle is 30 degrees, if I say that theta is 30 degrees, can I solve mathematically what my Vx value is going to be? Absolutely I can. I would go 10 meters per second times the cos of 30 degrees. Okay, you can get a number for that. Multiply 10 times cos 30, you get the value of that x component. Okay, Vy is going to be equal to the magnitude of the actual vector times the sine of the angle, which is 10 meters per second sine 30 degrees. Does this make sense? Yeah? Okay, now, playing with trig here, if I've got like any triangle, what do I know this angle to be over here? I know this angle is going to be 90 degrees. If I know that that's 30, what's this guy going to be? Okay, this is all math you've done before, right? So if I gave you the actual, let's say, you know, I gave you this number for y and I gave you this number for x, how would you go about finding the actual magnitude of v? How would you do that? Mathematically, what would you do? Oh, look at that. Vr, okay, or v itself, get rid of the r, v itself is going to be equal to the square root of Vx squared plus Vy squared, right? So even if those numbers are negative, even if this was a vector pointing in the fourth quadrant, let's say, where it had a negative x and a negative y, those negatives cancel out when you're squaring them, do they not? So you would still get a positive number. And that makes total sense because the magnitude of a vector should be absolute. There's no positive or negative to it. The positive or negative is going to come from the direction that we figure it out. We're going to figure that direction out later. Okay? So to determine the magnitude of a vector, to determine the length of the arrow, you're going to use this formula. to determine the direction of the actual vector, you're going to use the same x and y values, but you're going to use a different form of trigonometry. Okay? The inverse of tan is going to be equal to the absolute value of the Vy component over the absolute value of the Vx component. Every year, somebody swaps these and gets the wrong answer. Be mindful that it's y over x here and not x over y. Okay? Now, this is going to be equal to your alpha angle. And I know that some of you right now are like, what? What is alpha? What is theta? I don't get it. Well, here's the deal. Okay? Here's the deal. For this actual vector way up here that we were working on, if we scroll back up here, for this guy, okay, our theta is going to be the same as our alpha. They're both in it's in the first quadrant. It's the only angle. But if I'm looking at this guy down here, okay, and I've got my x component and my y component, this is the angle that I'm going to end up finding. All right? Is that the direction of my vector? This is where we have a difference between alpha and theta. The only time alpha and theta are equal to one another is when the vector has a positive x and a positive y. As soon as it doesn't have both positives, you're looking for your alpha. And depending on what angle you find here, okay, depending on what angle this ends up being, you're going to determine that if you find this actual angle, what would be the actual direction of that vector? So in this case, it would be 360 degrees, so theta would be equal to 360 minus whatever you figure out for your alpha. And if you want to just make sure of that, you'd sit there and you'd start at your 0 and you'd go all the way around. Okay, that is your theta, whereas your alpha is just the actual vector. Okay? What's Vy going to be equal to? Vry going to be equal to? V1y plus V2y plus V3y. Can I figure out what my V1x is from the information I was given? Yeah, I can. What formula am I going to use for each of those little V1x, V2x, and V3x? What little formula am I going to use? I am going to use, for my Vx components, I'm going to use V cos theta. And I have each of my thetas here. I have each of my angles are different for every one. And then for my Vy's, what am I going to do? V sine theta. So I'm going to get a sum of each of these. And based on these sums, I am then going to say VR is going to be equal to Vrx squared plus Vry squared. What does this VR get me? What does this get me? What answer is this? I need two things for every vector. I need a magnitude and I need a direction. This is the formula for which one of those two? Magnitude. How do I get my direction? I get my direction, okay, by going the inverse. So I'm going to say alpha is going to be equal to the inverse tan of absolute Vyx, or sorry, Vry, not x. Don't need to confuse you anymore. The absolute value of Vxr and then I'm going to figure out what my actual angle, my alpha angle is. And depending on, if you actually just doodle this out on a piece of paper, you're going to get an idea of where this actual vector should end up. Okay, what quadrant should this kind of be in? All right? And then you will know how to set up what your alpha is going to actually be. You'll figure out what the final theta or final direction is. Okay? I want you to actually do this one on a piece of paper.